Welcome to another class with Mathemasoft. In previous classes on partial fractions, we have solved questions in the area of linear denominator and when we have a repeated factor as the denominator. So in this video, we'll be solving questions on when we have fractions in which the denominator has a quadratic term. So now, what we mean by this is that when you check the denominator of the fraction, of the rational fraction, so observing, you see that we have a term as a quadratic term in it. Now, this quadratic term, the actual thing is that it's a quadratic term that you cannot factorize. Okay, so if you have a quadratic denominator that you can factorize, that one is actually different. So you have to first factorize it to get a simplified denominators. But in this case, when you have a quadratic denominator that you cannot factorize, then how do you split such a fraction into partial fraction? That's exactly what we want to look at. So we have these two questions. So let's get to work. So we have solution. And then number one, we have 5x. Okay, we have x squared plus x plus 1. Now, if you want to learn more about this in terms of the fundamentals to this, I've actually treated this in the second video that I posted on partial fraction. So I've already watered the ground for it. So this is just for us to now practically solve an example. So let's first separate this into its fraction. Of course, because we cannot factorize this, so it's going to be a partial fraction on its own, and then we have the term in x minus 2. Okay, so this is how we are going to separate it. Now, recall from the second video that I mentioned that when you have a quadratic denominator, your partial fraction must always be written in the form that the term of the unknown in the numerator must have a power, just by one less than the power of the what of that in the denominator. Now, this is what I mean. Now, when you look at this quadratic term, you see that the power of x there is actually what? 2. That's the maximum power of x there is 2. So the maximum power of x that you are going to write in the numerator must be x raised to power 1, such that it will be by 1. Okay, the difference between the highest power of x in denominator and the what highest power of x in the numerator, the difference between them will be by 1. So if you say 2 minus 1, it will give you 1. So that means that if you have x squared plus x plus 1 in the denominator, what you can have in the numerator is something of this form, ax plus b, such that if this one is a quadratic, okay, this one will be linear. All right, so that's how the numerator of this kind of a quadratic function can actually be. So let's get to that. So this can be written as ax plus b, because the power of x here, is actually 1, and that is the difference between the power of x in numerator and denominator is already 1. 2 minus 1. So I'm saying this because you may have a kind of function in the denominator that look like polynomial. Maybe you have x raised to power 3. So by the time you are separating the numerator must actually be in the form ax squared plus bx plus c. That's if your denominator is actually in form of polynomial that you cannot factorize. Please, that you cannot factorize. If you can factorize it, you split, you simplify the denominator. If you cannot simplify the denominator, then the power of x or any unknown that you have in the numerator must just be by 1 less than that of the power in the denominator. So please note that. So now c, we can use c, constant c. for that, and then this is how the splitting will be. And then we can continue by saying that our LCM will be x squared plus x plus 1, and then we have x minus 2. So here, this, that's x squared plus x plus 1 in this will give us x minus 2. So that will be times what we have up there. So that's, pardon me, that's b. I have to write that in a better way. So that's b bracket x minus 2. And then we have plus c into bracket x squared plus x plus 1. So we have the same denominator now, left and right hand side. So now we can compare the numerator. So our numerator is 5x equals to ax plus b bracket x minus 2, and then we have plus c into bracket x squared plus x plus 1. So if you observe this, we can first eliminate. Let's eliminate a and b. That means that if we put x equals to 2, that will eliminate this. It will make this part to be what? 0, because 2 minus 2 will give us a 2 minus 2 here will give us 0, and that's that. So we can say 5 bracket 2, everything here must have become 0, then plus, c, we have 2 square plus 2 plus 1, okay, and then that will be 10 equals c into bracket 4 plus 2 plus 1. So that will be 10 equals 7c, okay, and c equals to 10 divided by 7. Okay, so that's what we have as our c. Now for a and b to be gotten now, so we may have to actually do a longer expansion. So let us expand 5x equals ax plus b bracket x minus 2, okay, plus we have our c bracket s square, okay, s square plus x plus 1. Okay, so let's do our longer expansion. That will give us 5x equals, so this will be ax square minus 2ax plus bx minus 2b plus cs square plus cx, a plus c. Let's collect the like terms together. So we have 5x equals as square and this, that will be cs square. Now the terms in x, xx plus bx, another one here, plus cx. Now the constants, our constant is here, minus 2b, and then we have plus c. So we have 5x equals a plus c. So s square will be out. We have plus minus 2a plus b plus c. X is out. Okay, and then we have plus minus 2b plus c. So this is what we have. So if you look at this, I can write my left hand side as 5x plus 0. So that's what it looks like. So the term is in x square must have had the coefficient of 0, this x. So it looks like a quadratic expression already, so that you can easily compare it to this side where you have a plus c s square plus bracket minus 2a plus b plus c, that's x. Just trying to manage the space. Plus minus 2b plus c. So that's what we have. Now let's compare. So we can see that a plus c is equals to 0. And we already know that our c is 10 over 7. 10 over 7 equals to 0. So that means that our a equals minus 10 over 7. Okay, that's just pretty straightforward. So we can take this also and equate it to 0. That will be minus 2b, okay, plus c equals 0. So that will be minus 2b plus 10 over 7 equals to 0. Minus 2b equals minus 10 over 7. And then divide both sides by minus. So that would have given us 2b equals 10 over 7. Multiply both sides by half. Okay, so that you can remove that 2. 2 cancel 2 here. So that will be b equals 2 here 1. That's 5. That's 5 over 7. Now we have gotten all our constants, all our unknown rather. So we can say therefore all the unknowns, let's take them out. Now they are known. Our b equals 5 over 7, and then our c equals 10 over 7. Now that we have this, so we can now rewrite our partial fraction. Let me just copy this. We have to rewrite our partial fraction. Okay, let me copy that here so that we can write. We can write our partial fractions. Okay, so now editing this now, let's edit it. That means that this is a, b will be out, c will be out. So what we have is minus 10. Okay, let me take that x also out so that I can write it clearly. So that's minus 10 over 7 x plus 5 over 7. Okay, and then we have 10 over 7 here. So the way we can rewrite that now will be for us to actually find the LCM here. That will be 7. Okay, so that means that what we have here is minus 10x plus 5 up there, and then we have x squared plus x plus 1, and then we have plus. This will automatically become 10 over 7 bracket x minus 2, and this also will become minus 10x plus 5 over 7 bracket x squared plus x plus 1, then plus 10 over 7 into bracket x minus 2. Okay, you can leave your answer like this. And if you're writing, maybe jump, they can actually switch this around. Instead of writing it as a minus 10x plus 5, they may write it as 5 minus 10x. So you should know that what this is actually what the same with this, of course. So, but you can leave your answer like this. All right, thank you very much for staying with me on this video. In the next video, we'll be solving question number 2. So I hope you do have a good understanding of this. Please share this video out and subscribe if you have not done so. My name is Mr. Legend, and I'll be with you in the next video. Thank you. Bye for now.